Okay, so this is what you have to do for the assignment. The assignment says that you have to write a C program for Linux that uses the fork system call for 3 iterations, right? So this is just like the lab we did. So when you call fork in a loop, you understand when you call fork in a loop, you understand that multiple processes are going to be created. So for example, the first you know parent process, it started at, for example, 0. So this I'm using for seconds, the time, right? So it started at 0, and the name of the parent process, let's call it P1. So it started at P1. There are two times that are reported that can be obtained for a process. One is called the wall time and the other one is called the CPU time. Wall time is the time that the process takes to fully run from the beginning till the end, from the starting of the code till the very end, until it finishes execution. So P1 starts over here, and for example, P1 ends at let's suppose 100 milliseconds, right? So all of this time is for, let's suppose, P1. Okay, so this is the time for P1. P1 starts over here, and P1 ends at 100, right? So this is the first thing. This time for P1 will be called the wall time for P1. This will be the wall time for P1. Okay, but P1, as I've said in this statement of the lab, no, sorry, assignment, that whenever a process forks a new child, it will wait for the child to finish execution. This is the first thing. And the second thing is, before going into the wait, every child process runs a loop that increments a local variable in a for loop for 100,000 times. So it is just a way of keeping the CPU busy for 100,000 cycles. But obviously, this statement leaves process P1 for waiting in the loop. So immediately, whenever the new child process is created, P1 will go into the wait, right? So for example, this was the time number, let's suppose 10, when P1 went into wait. So here I can say P1 went into wait for uh, its child. Let's call the child process P2, right? So it means that starting from this to this time, this was the only time when process P1 was running in the CPU. But for all of this time, for as long as P1 waits for the child process P2 to finish execution, this time will be added to the wall time, but actually reported inside the wall time, but it will not be reported with the CPU time. CPU time will only be this time. For example, this is the last part, the last 10 milliseconds, maybe, when P1 returns from waiting, and it executes something in its code. So this time plus this time, this will be the CPU time. So you can find it out using system calls. And if you go to this website over here, you will find the method how you can how you can find out wall time and CPU time for a process. So if we roughly look at this picture and we tell what is the wall time for P1, you can say 100. What is the CPU time for P1? 30 plus 10. I'm just making these numbers up, just examples. So maybe 40. So 40 is the CPU time, and all of the time when P1 kept waiting for P2 to finish execution, that will be the idle time for P1. But of course, in this time, process P2 is running. So let me draw over here that this is all the time that process P2 is maybe running. So this is the time for P2. For example, it started at 15 and it ended at let's suppose 90, right? So all of this time is the time when P2 was running. Now P2 again forks another child, because this loop that we're talking about, this loop is going to fork different children in different processes. So P1 is again going to fork yet another child, which will increase the weighting of P1. And while P2 is going to do its own thing, and its own thing is it has to do three things actually. The first thing it has to do, it has to go into loop for 100,000 times. So P2 will take more time to execute. This is the first thing we know. Then it forks a new child, and while the new child, for example, let's call the new child process P3. Until the new child process P3 executes, P2 stays in waiting. This is the waiting time. So again, if someone asks you what is the wall time for P2, this is this time. And what is the CPU time of P2? This is only this time, this one. So I want you to draw a picture similar to this, which takes into account all the wall times and CPU times of all the processes, and try to show for which times process P1 was idle, for which times process P2 was idle. And I want you to try to figure these times out using uh, time durations. Even though if you want to get clock ticks for absolute time, for example, what was, instead of 0, what was the actual CPU time in milliseconds when since the CPU is up. So there is a time for that as well. So you can also find out that time and draw this graph properly, right? So then, for example, another P2 forks another child, and from here you see that at, for example, 35, a new process starts, and again the new process goes into a loop for 200,000 times, and P2 has to wait for this process P3, right? And this process P3 will keep indirectly everyone wait, P2 and P1. This process P3, since it's a child of P2, it is going to keep P2 into waiting, and because P1 is waiting due to P2, P1 is also waiting indirectly due to P3, right? So I hope this makes the things more clear. And if you still don't understand, you can ask me questions and I will try to answer them, right? So this is how I expect to see the picture. The statement is not vague. The statement is very clear. It is mentioned in steps here in the assignment. And the first part is that you have to write the code that reports the wall times and CPU times for all the processes. And the second part is that you have to draw a graph similar to this. And my hope is that we will get some time durations which are not accounted for at all. Those are the times which are going for background processes which don't belong to us because of CPU scheduling from other. But you should not, you should find this discrepancy out when you draw this graph. So that is my objective, that you should be able to find a problem with the graph. While you draw the graph, you will find tiny amounts of time which you cannot fit into the graph with your processes anywhere. So those are the times that are actually going to towards those processes which don't belong to your program. Those processes were scheduled by the operating system inside your program due to their priority or other factors. So that is the assignment. I hope you understand the assignment and give it a try. It's not that difficult. Okay. See you. All the best.